All right, this is our first trig lesson, and thank you guys for being here today and watching this. Kind of the plan with these two lessons is that we're going to have the first lesson and a worksheet, and then in your next class, you're going to have a shorter lesson and a shorter worksheet, and you will have this class and the next class period, which is a block, to work on both of those. So let's just go ahead and start with this one. This should be a review from you because we covered this last year in geometry, but we do want to come back and hit it again because you will need this when you take your ACT test eventually. All right, so first of all, some terminology that you're going to need is that in trig, oftentimes they use Greek letters. This is called theta to name an angle. They would use that instead of an x or y. It's just a way of naming something with a variable. So again, that's theta. It's spelled T-H-E-T-A. Now, if this is the angle that we're talking about, and I always like to mark it, we name the other sides in relation. So if you are standing on this angle, and if you throw a ball straight across, the side straight across is called the opposite. And we know that right across from the right angle is the hypotenuse. And then the side that is adjoining it is called the adjacent. And that's a leg. So you have two sides that make this angle, but one is the hypotenuse, the other one is the adjacent. All right, so trigonometric ratio, that is a ratio of the lengths of two sides in a right triangle. Now, the first trigonometric ratio we're going to talk about is tangent, and that is defined as the opposite leg over the adjacent leg, and that's talking about the lengths. Now, this is not in your notes, which you don't have a note guide anyway right now, but just so you have an understanding of these are ratios. And we talk, like if you look at this picture right here, if you remember back to geometry, we would say that all three of these triangles are called similar, which means the sides are proportional. So if this is your 30-degree angle, if you look at the ratio of the opposite over the adjacent, it's 2.9 over 5, which is equal to 0.5774. If you're looking at this triangle, okay, the side opposite the 30 is 5.8. The side adjacent would be 10. 5.8 over 10 is also 0.5774. And looking at the larger triangle, we end up with the same thing. This is 8.7, the opposite. The adjacent is 15, and that's also 0.5774. So as you can see, anytime you have a 30-degree angle in a right triangle, the opposite over the adjacent has the same ratio, and that would be called the tangent. So back when I was in school, this was a picture of my math book, actually. We used a chart. We did have a calculator too, but we used a chart in the back of the book quite a bit. And so let me move this a little bit here. This talks about the measure of the angle. If you go down to a 30-degree angle and go over to tangent, which you can't really see that because this is in the way, but this is the tangent, it's 0.5774. So when you know that angle, what the tangent is, you can use that to find missing sides. So to find tangent 30 on the chart, you just go to 30, go over to tangent. Like if you wanted the tangent of 71, you would go to 71, go over to tangent, it's 2.9. You also should be able to find that on your calculator. Now, if you're using a calculator like I used in class, you just type in tangent, and then you type in the number, and that will give you 0.5774. You should try that right now with your calculator. If you're using a different type, or if you're using a calculator on your computer or on your Chromebook, depending on the type, sometimes you can type in tangent and 30 and it will give you the 0.5774. So check that out. Other times you might have to type in 30 and then hit tangent, and that will give you 0.5774. So it just depends on the type of calculator you have. So make sure that you know how to run your calculator. All right, so here's another one. Another thing we need to talk about is with right triangle trig, oftentimes they label the triangles A, B, and C. C is always the right angle. This would be A, and this would be B. The main thing you need to know is for the A and the B is whatever A is, the side across from it is little a. Whatever B is, the side across from that is little b. Whatever C is, which is usually the right triangle, the side across is little c. So if you're talking about the tangent of theta, it would be little b over little a, opposite over adjacent. All right, so let's do some problems like you're going to do in your worksheet. It says find the tangent of S and the tangent of R. Okay, so first we're going to find the tangent of S. Here's the big thing. If you want to do well at this, what you need to do is label your triangles. I think that helps so much. So mark the angle S. This is the hypotenuse. Straight across, if you threw a ball, this would be the side you'd hit. This is the opposite, and this is the adjacent. So the tangent of S is opposite over adjacent. So the opposite is 80, the adjacent is 18, and we always reduce our fractions. And so that would be 40 over 9. And in addition to that, it says to write it as a fraction and a decimal. So that is equal to 40 over 9 is 40 divided by 9, which is equal to 4.4444. In Trig, they go out 4 places, just because that's what is on the chart. And so go out 4 decimal places unless it says otherwise. Now it says find the tangent of R. So tangent of R, well now we're talking about angle R, which means it's this one, and so we're no longer using these for the opposite and adjacent. If you're standing on R, the opposite would become this, and the adjacent would be this one. And so the opposite is 18, and the adjacent is 80. So that would be 9 over 40. And if we write that as a decimal, 9 divided by 40, it's 0.225. That's only three digits, so we want 4, so we're just going to add a 0 there. All right, so that's what you're going to do for your first problems. So let's do another one. Find the tangent of J. So first thing we do, label. Here's your hypotenuse. Here is the opposite. Here is the adjacent. So the tangent of J is the opposite over the adjacent. And then just reduce that. 8 goes into there 3 times. 8 goes into there 4 times. So that would be 0.75. And we'll add 2 zeros. Now, when you are just looking at the ratios, we're not looking at typing in tangent into your calculator. You're just writing the ratio and writing that ratio as a decimal. Next, we're going to use this then finally. The purpose of doing this is to find side lengths. So we're going to mark the angle here. We're looking for the side length, but this time notice they don't just write theta, they give us an angle, which means we then can put that in the calculator to get a number. So mark the angle, label the sides. This is opposite, this is the adjacent. And then write it out. Write the tangent of the angle, in this case it's 32, equals, remember that's opposite over adjacent, so the opposite is 11, the adjacent is x. And now we have to solve that equation. Now there's a few ways to do that. One way that's just a surefire way, you have a fraction on the side, write this over 1, so you have a fraction here. And if you just cross multiply, you have x times the tangent of 32 equals 11. Now divide both sides by the tangent of 32. So x equals 11 divided by 17.6. Okay. I'm just looking for a different calculator real quick because mine is not, I want to double check. I don't have, mine were all gone when I came. Oh, there is one over there. 1 second. Okay, I'm in business. So 11 divided by tangent of 32. Yep, 17.6. All right, let's do another one. We want to find the value of x. So first thing you do, mark the angle, label the sides, opposite And then this would be the adjacent. Remember, this is the hypotenuse, but they didn't give us a number there, so we won't worry about that. So the opposite and adjacent, that's tangent. So the tangent of 61 equals the opposite over the adjacent. And again, I'll write that over 1, and I will cross multiply. So you have x times the tangent of 61 equals 22. And then to get x by itself, you divide both sides by tangent 61. So you have 22 divided by tangent 61. And that equals 12.2. And we'll do one more. Okay, so this is the opposite. This is the adjacent. This across here is your hypotenuse. So opposite and adjacent, that's tangent. So tangent of 56 equals x over 13. We'll write that over 1, and we'll cross multiply. So x times 1 equals 13 times the tangent of 56. So we type in 13 times tangent 56, and you get 19.3 approximately. Now, one thing I want to clarify is whenever you have a problem like this where you have tangent of something times a number, first put in the number, the integer, or the number, or the it doesn't necessarily have to be an integer, it could be a decimal number too, but put that in first times the tangent of the number. If you were to type in tangent 56 times 13, your calculator might actually do 56 times 13 and then take the tangent of the whole thing, which would be wrong. So put the plain number first and then go times the tangent of the angle. All right, there are two other trig functions we're going to deal with, and that would be sine, which is defined as the opposite leg over the hypotenuse, and cosine, which is the adjacent leg over the hypotenuse. And if you'll recall, we use the acronym SOHCAHTOA to remember these. So S stands for sine, which is the opposite over the hypotenuse. So sine is the opposite over the hypotenuse. Ka stands for cosine, which is the adjacent over the hypotenuse. And toa, like we said, is tangent, and that's opposite over adjacent. So sine, cosine, and tangent. So it says find the sine of x. So we're going to, in this first example, mark the angle and label the side. So this is the opposite. This is the hypotenuse, and this is the adjacent. And now we want to find the sine of y. Now remember, sine is opposite over hypotenuse. Let me just write this down here real quick. So, SOHCAHTOA. Opposite over hypotenuse. So the opposite of y is 15, and the hypotenuse is 17. And 15 divided by 17 is 0.88235, which rounds up to 24. And we're just going to do we'll go ahead and do the other one. Now let's say we want to find the sine of y. We'll use another color. See, that was the sine of y. We're going to do the sine of x now. So now we'll label. This is the opposite. Here is the hypotenuse. Erase that. And here is the adjacent. Okay, so the hypotenuse is across from the right angle. There's your adjacent. So your sine of x would be, again, the sine is opposite over hypotenuse. So that would be 8 over 17. And 8 divided by 17 is 0.4706. So that's how we do a problem like that. All right, now we're going to find cosine of angle R and cosine of S. So angle R is right here. We're going to mark it, label. This is the opposite. Here is the adjacent. And notice we don't have the hypotenuse here. Well, in this case, we have a right triangle, so you can use the good old Pythagorean theorem, which remember is a squared plus b squared equals c squared. And if you'll recall, the c is always the hypotenuse. So the A and the B can be the two legs. It doesn't matter which you put for A, what you put for B. So 9 squared plus 12 squared equals C squared. 9 squared is 81 plus 12 squared is 144. And that gives you 225. And now we want C, not C squared, so you have to take the square root of both sides. So C equals 15. So that's a good review of the Pythagorean theorem. And this is the hypotenuse. All right, so cosine of R is, cosine, remember, is the adjacent over the hypotenuse. So your adjacent is 9, your hypotenuse is 15. And if we write that as a decimal, you get 0.6, and we'll add 3 zeros. All right, let's also find the cosine of angle S. Okay, so if I'm looking at S, the opposite becomes 9, the adjacent becomes 12. So cosine is the adjacent, which is 12, over 15. And 12 divided by 15 is 0.8. There, just like that. All right, let's do a word problem. You want to build a skateboard ramp with a length of 14 feet, an angle of elevation of 26 degrees. You need to find the height and the length of the base of the ramp. Okay, so let's just talk about this a little bit. So the skateboard ramp has a length of 14. When it talks about the length of the actual ramp, it's talking about like the length of the board you would have to use to build that ramp. So this is 14 feet. The angle of elevation means that if you're on the ground, it would be the angle that you turn up to look up, okay? So this is 26 degrees. We want to find the height of the base of the height of the ramp and the length of the base. So this is the base of the ramp, so this is y, and then the height of the ramp is the distance from the ground level, the perpendicular distance up to the top. Okay, that's going to be your height. So what you want to do first, label. Label, label, label. I'm huge on that. So here we have, let me find a good color. This is your hypotenuse. It's not a great color. This is the opposite. And this, if you're looking at your 26, this is the adjacent. So what we're going to do to solve this is we have to find one at a time. We're going to pick one. First, we're going to find x, okay? We're going to find x. So we're going to use the opposite side, this, and we have to look at what number we have. We have the hypotenuse. So which trig function uses the opposite and the hypotenuse? That would be sine. You look at SOHCAHTOA, opposite and hypotenuse, it's sine. So the sine of 26 equals the opposite, which is x, over the hypotenuse, which is 14. Now we cross multiply. X equals 14 sine of 26, which equals 6.1. All right, now let's find the other side, y. Okay, so y is the adjacent, and again, we'll use the one that they gave us, the hypotenuse. So adjacent and hypotenuse would be cosine. So the cosine of 26 equals the adjacent over the hypotenuse. And now we cross multiply. So y equals 14 times the cosine. Let me write it this way. 14 times the cosine of 26, which is 12.6. So that's what the y, the length of the base is, 12.6. So the big thing is with word problems, or if you have a missing side, is label and then circle the side you're looking for, and the other length that you have, circle that. Determine which one of the trig functions you'll look at based on the sides that you have circled. Here's a problem that's in your worksheet. It says an escalator at a shopping center is 200 feet, 9 inches long, and rises at an angle of 15 degrees. What is the vertical rise of the escalator? Okay, so we're going to draw a picture. Make sure you draw lots of pictures here. So the escalator, oh, I miss being at a shopping mall. An escalator at a shopping center is 200 feet, 9 inches long, and it rises at an angle. So if this is the ground, the angle that it rises is 15 degrees. What is the vertical rise of the elevator? So from the very tippy top, the distance, the perpendicular distance down to the ground would be the vertical rise. So we'll call that x. That's what we're looking for. So first of all, we need to do some converting. We have 200 feet, 9 inches. So 200 feet, let's change that to inches. So 200 times 12. So 200 times 12 is 2,400 plus 9 inches is 2,409 inches. So let's just write this as 2,409 inches. So that's what that length is. Now, next thing we want to do, like I said before, is label the sides. This is the hypotenuse. If you're standing here, throw the ball across. This is the opposite. So which uses the opposite and the hypotenuse? The opposite and the hypotenuse, that would be sine. So we're going to use sine. So the sine of 15 equals the opposite, which is x, over the hypotenuse, which is 2,409. So we'll cross multiply. And you get 623.5 approximately. 623.5, that would be inches. All right, so that would be, we can at least leave our answer that way, round to the nearest inch. Yep, which 624 if we rounded it. Okay, this is your worksheet time now, so you can go ahead and either look at that on Schoology. Yeah, you won't have it, so look at it on Schoology and you can write your answers on another piece of paper. Make sure you label that it's Trigonometry Practice Worksheet 1 on the top. And for number 1, we'll do that first one together. It says find the ratios for sine D, cosine D, and tangent D. So the first thing you do, and I would like you to draw the triangles on your paper and label them. The thing is, guys, you're going to have to do a really good job on the homework that you send in because we're not going to have tests like we did before. The tests aren't going to count as many points, and so I'm really going to look at your homework to make sure that you do a good job. So copy the triangles, label. Here is the hypotenuse. This would be the opposite. This is the adjacent. So we want the ratios for sine of D, the cosine of D, and the tangent of D. And I think we'll just write the fractions. So sine is, I'm going to write SOHCAHTOA here. Sine is opposite over the hypotenuse. So the opposite is 4, the hypotenuse is 5. Cosine, the adjacent is 3, and the hypotenuse is 5. Okay, adjacent over hypotenuse. Tangent is opposite over adjacent, 4 over 3. And those are your answers. That's it. You should reduce the fractions if you can. Now, when you get to this problem right here, if you end up with a radical in the denominator, remember you need to try to rationalize the denominator. So I'm trying to think right here if you'll get one. You maybe won't. And I do have the answer keys posted too. And that is the same thing in that problem here. Let's do number, we'll do number 7 here. Okay, so what you want to do is mark the angle and label what you have. This is the hypotenuse. This would be the adjacent. And which trig function uses those? Well, that's cosine. So you write cosine of 34 equals the adjacent over the hypotenuse. Cross multiply, x equals 8 cosine 34. And that gives you 6.6. We'll do another one real quick like here. This angle's, mark the angle, label, this is the opposite, this is the adjacent. So that is tangent. So the tangent of 55 equals the opposite over the adjacent. And cross multiply. Oh, I typed it in wrong. 33 tangent 55 equals 47.1. All right, so that's that page. On the next page, you have some word problems. So we already did this one in your homework. Let's look at this ladder problem. A 12-foot ladder is leaning against a wall and makes a 77-degree angle with the ground. So here we have a wall. Here is the ladder. This is the one that's leaning right here, and it's 12 feet. That's how long the ladder is. It's leaning against the wall. How high does the ladder reach on the wall? All right, so that's talking about the tippy top of the ladder, the perpendicular distance down to the ground, and so that would be the x. And the angle here is 77. And so now label the sides and figure out which trig function you're going to use. Let's look at the setup of this one. The ramp on the back of a moving van is 3 feet high and rises at an angle of 25 degrees. How long is the ramp? Okay, so here's the moving van. Here's a ramp on the back of it. And it's saying that it's 3 feet high. So the highest part, the perpendicular distance to the ground, is 3 feet. All right, here's the ground, and the ramp rises at an angle of 25 degrees. How long is the ramp? So we'll put an X right there. Next, a rope attached to the top of a tent is staked to the ground. Okay, so here's a tent. All right, and here you have a rope, and it's attached to the top and staked to the ground right here. The rope is 4.5 feet long. An angle formed by the rope and the ground is 46 degrees. How far from the center of the base of the tent is the rope staked? Okay, so here's the center of the tent right here. All right, and so what does it say here? The angle formed by the rope and the ground is 46. How far from the center of the base of the tent? So how far is the rope stake from here to the center? So this would be X. So this is the triangle we're looking at right here in this problem. It's a little bit confusing. So here's your X, and that's 4.5 feet long, and we want to round to the nearest foot, so you can just leave it as 4.5 feet. All right, so go ahead and finish this assignment, and just, this will be due on Friday, so you have time to work on it. You don't have to get everything done now. I know this teaching lesson was a little longer, but tomorrow's will be a lot shorter. So let me know, email me if you have questions. I am so happy to help. If you have makeup work that you need to get done, connect with me as soon as possible so we can get started on that. Thanks, guys. Have a good day.